Math sure has been easy for the past few lessons. We talked about the laws of equalities, something we know since primary school. The good old days, right? Let's stay there for a while longer as we discuss inequalities. An inequality contains two numbers which have one of these symbols between them. If you have a greater than symbol, the number on the left is larger than the one on the right. But if you have a less than symbol, the number on the left is smaller than the one on the right. Just like the laws of equalities, the ones for inequalities can be self-evident, like the trichotomy property, a big name for something that's common sense. If you have two real numbers, then one of them is either equal to the other, or larger than it, or even less than it. Only one of these can be true at the same time. Let's say we had two numbers, 5 and 10. What's their relationship? 10 is always greater than 5. It's simply not possible for it to be both greater and lesser than 5, or greater and equal. That seems ridiculous. Now, do you remember the transitive property for equality? It's similar for inequalities as well. If A is larger than B and B is larger than C, then A is definitely larger than C. It becomes obvious if you write the inequality along a number line. Now we can clearly see that A is greater than C. And if we plug in some actual numbers, it all gets clearer. The law holds in reverse as well. When A is less than B and B is less than C, then A will definitely be less than C. Easily understandable on the number line. Let's move on to the additive property, whether A is greater than or less than B. Adding C on both sides doesn't change the inequality symbol. Once again, we use our trusty number line. Let A be 2 while B is 3. Adding C to both numbers just shifts them along the line without changing their relative sizes. Like adding 4 to 2 and 3 makes them 6 and 7. What's the difference between their old and new values? Still 1. What if we added two inequalities together? Let us take our two inequalities with four real numbers, A, B, C and D. Let's add them up. Did you notice? The inequality symbol is still the same. And if you started off with the other symbol, the property still holds. Let's use some numbers again. Now add them up. The left side is still larger than the right side. However, the story changes a little with the multiplicative properties. Using A, B and C again. Where A is greater than B, multiplying C with A and B doesn't change the inequality symbol. This is only true if C is a positive number, which means it's not negative nor 0. You can see it on the number line where A and B move towards the right when multiplied by 4, but B continues to be smaller than A. Even if A was smaller than B, it would remain smaller even after multiplying both sides by C. Now, let's change the value of C to a negative number. We will make it -4 and set B to be smaller than A. What happens on the number line? The inequality has flipped. B becomes greater than A. So, if A is larger than B when C is negative, multiplying with C flips the inequality sign. And if A is less than B initially, the symbol flips the other way. Now, let's wrap it up with one final multiplicative law. How do you multiply two inequalities together? Easy. Just like in addition, multiply both left sides together and then the right. Notice both inequalities have the same symbol, and so does their result. And if you started off with the other symbol, the same principle applies. Like in this example, When we multiply the inequalities together, the symbol doesn't change because the left side is still larger than the right side. And that rounds up all the laws. Congrats! You have made sense of the mathematical world. Now, any kind of binary operations with real numbers won't be a problem for you. However, we think practice makes perfect. So, let's meet in the next video to tackle some example questions.